2600 BC in ancient Egypt, the Egyptians figured out a way to build pyramids. And while it's still a mystery all these thousands of years later exactly how they did that, there's some basic theories on how they did it. And what makes it interesting is that a couple of the theories would indicate that they had already figured out what a plain bearing was all about. There's one theory that believes that they used giant sleds pulled by hundreds of people up ramps, and these sleds had smooth wooden runners on them that they would pull up a crushed granite ramp, sometimes with water as a lubrication, and there's even some that believe they used the fat of animals as a grease. There's another philosophy that they in fact did use wheels. In this case, the whole concept of wheels was large granite wheels with square wooden axle blocks. And what makes it very interesting is that there's some archaeological evidence that inside those wooden blocks was a copper bearing, which could be indicative of the very first self-lubricating plain sleeve bearing. It's all theory, of course. Nobody knows really how the pyramids were built. There are some that even believe that the aliens built them. I kind of like to think that that might be the way they actually got built myself. But jump ahead several hundred years, several thousand years actually, to the 1500s, and Leonardo da Vinci, in some of his drawings, actually showed what appears to be the first ball bearing. In fact, it was a design that he had come up with for his first concept for a helicopter, and this was in the 1500s. Jump ahead another 100 years, and in the 1600s, Galileo came up with the same concept. But this time he was showing it as a caged bearing, which would actually reduce the friction. Several more years passed. There were lots of new inventions that came along that required different types of bearings made of wood, bearings made of polymers that were developed out of natural resources like plants. And it wasn't until the Industrial Revolution that we finally reached a point where some of the materials that we're now using still today were invented. 1800s, late 1800s, Isaac Babbitt, who was a goldsmith in Massachusetts, developed a way of making a tin alloy, which became known as Babbitt, obviously named after the man himself. Babbitt bearings today are still in use in a lot of industrial applications, and especially in the hydro field for power plants and so forth. Around that same time, the early 1900s, was where the first real polymeric bearing came into being, when a gentleman named Leo Baekeland found that by heating up phenolphthalic, you could actually make a moldable resin, and that resin became known early on as Bakelite. And Bakelite is still a product that you can find online, used primarily for jewelry and knobs for ovens and things like that. But most of us know it as micarta or NEMA grade phenolic sheets, things like that. That's all based on the invention of Leo Baekeland. Now we jump ahead into the 20th century, and that's when things really got to change. Hi, I'm Dave Bearing, Technical Director here at TriStar, and welcome to Tech Talk. This is a little bit of a different type of Tech Talk because we're not talking about specific materials or specific applications, but instead I'm pleased to introduce to you our newest white paper. And this white paper is specifically talking about plain bearing designs on the different types of materials and forms that these products can take, and more importantly, how they're applied. This is a 32-page white paper that covers a lot of different information. We start early on with some of the basics of why polymer-based plain bearings are important. What's the whole concept of self-lubrication? What are the advantages of a plastic bearing versus a metal bearing? Then we get into some of the basic information on the physical properties, the characteristics of plastics and how they're applied in bearings and seals and gaskets and so forth. These properties, we'll go into them very specifically and talk a little bit about why they're important when it comes to a plastic bearing design. Then we're going to talk a little bit about the whole concept again of self-lubrication, tribology, some of the cost values of different materials. We'll talk about why some materials cost more than others. It's like anything else in life, you get what you pay for. But you'll see some examples of some of the more expensive materials and why they're considered to be high performance products. We're also going to talk and really focus in on some of the basics of designing a plain bearing. What is PV? What is coefficient of thermal expansion, and how does it really relate to a plastic bearing? It's very important information. What about lubrication? Can you use lubrication or not? And we talk about hardware situations. We talk about a lot of different things that are important in the design of a plastic plain bearing. For those of you who have not seen some of our earlier videos, we really focus in plain bearing design on some key factors. What is the load? What is the speed? What is the operating temperature and the minimum and maximum temperatures? What are the environments going to be like? And we take all that into consideration and have a number of different materials we can choose from. As you can see from this triangle, or plastics triangle, there's a variety of materials we can use for plastic plain bearings. So it's important for us to get all the details put together early on so that we can be sure that we make the right selection for you. Or in some cases you may want to make that selection yourself, and that's part of what this whole presentation is all about, to help you understand better about designing plastic bearings and how it might work for your applications. Then we're going to look at some of the key materials that we offer here at TriStar. Our Rulon bearings, which is a whole family of PTFE based materials. Our CJ product, which is our filament wound composite bearing. Our UltraComp, which is our laminate wound, very high load composite bearing. And we'll talk about our Tri-Steels, which are the metal back bearings. And then we get into both engineering grades of plastics and high performance materials and talk specifically about some of their values. The most important thing that we hope you get out of this white paper is that there are many places already using plastic bearings in your life. You probably don't know it, but there are. And so we want to be sure that you understand all of the basics behind what makes a plain bearing work, where it doesn't work, and really to help you better understand the whole concept of plastic self-lubricating plain bearings. There's a lot of information. There's a lot of places that you can go for more information. If you, again, check under our resources, we have lots of other videos that talk about some of these specific things like coefficient of friction, PV, other basic design criteria for plastic bearings. We have a blog site, of course, that you can refer to, and we hope that you'll participate in the blog as you can. A lot of interesting things come up from conversations we have with customers, so we hope that you utilize that as a nice little training aid for yourself. We've also got a number of direct links that you can take to get into design information as far as plain bearing design worksheets, flange bearing, linear bearing. We have a lot of different worksheets for a lot of different applications, structural materials, seal applications, you name it. We've got a design worksheet for it, so we hope you'll utilize those. And anyway, we think that you're going to enjoy this. Again, there's a lot of thought that's gone into this white paper, and we wanted to make it interesting enough for you to read the whole thing. It's 32 pages, as I mentioned earlier, but also short enough to where you can get the basics of what we're trying to say here. I'd like to thank you for participating, for watching this video. I'd also like to take this opportunity to thank our friends at Quadrant. Some of the information we have used in the white paper was given to us by them, and a special thanks to Jim Hebel my counterpart at Quadrant. And again, we hope that you'll enjoy this white paper and that you'll learn something from it. Thanks for watching, and we hope to see you again on another Shooting Star.
That was a lot shorter.